So go ahead and look at some of the Our World headlines. See if you can relate to any of them. Our World, local heat wave seen a sign of global warming, i.e. Bend. Our World, psychologists tout surprising new findings. Our World, unemployment rate jumps from 7.6% to 7.8%. Our World, coffee makes your toenails turn yellow. Our World, CrossFit is good for you. Our World, CrossFit is bad for you. How many of these sound familiar? Whether the ones on the board or the ones I just half-jokingly said, right? All right, you read them all the time. Ones like it all the time, correct? What I'd like you to do is look at the mathematically literate world headlines and see how they say the same thing in a better way. Look at the one for global warming. Local heat wave not seen as meaningful indicator of global trends. How many of you guys have gotten the global warming talk now that Bend is going through January? Has that come up in discussion with anybody? See, told you. I'm not picking a side, FYI. I'm just throwing that out there. How many of you have heard that now, that we had this super warm June? Yeah, a couple of you, right? What's the problem with arguing that because we're having a warm January in Bend, because of the fact that I can ride my road bike to Bachelor, which is amazing, in the middle of December, what's the problem with proving global warming with that?
It's not really a trend. It has to go on for a long time.
A trend needs to be a long-term measurement, not a point in time. Thank you, Rachel. Another problem came to me in the form of a text from my father in Wilmington, Delaware, 2 nights ago. A foot of fresh powder on his back deck. His complaint, it's too light and fluffy to make snowballs. I'm like, are you seriously complaining about this? Every skier bone in my body was like, oh my god. Too light to make snowballs. But the point of the fact is, no trend exists from a single data point, and no trend or global trend exists from one localized data point. I'm not picking a side. I'm saying that doesn't prove nor disprove anything. That is just a random fluctuation in the system, potentially, isn't it? It could be a trend. I don't think Rachel's saying it can't be a trend or can't not be a trend. But we could also just be a random fluctuation in an otherwise normal system. We're going to talk about snowfall soon in this class, i.e. next week, Bend snowfall over the past 100 years. Our World, psychologists tout surprising new findings. Literate World, psychologists promise to replicate surprising new findings before touting them. Why is that important?
Because replication is no one can prove science.
Why is replication the keystone of science? Give me more. I love that statement, by the way.
You have to have a large sample size to choose if your results are independent or...
Why? Keep going with that, Serenity. That's 100% correct. How come?
It has to be repeatable.
Why? What could your surprising result be? Smoking is all of a sudden good for you. Right? I ran a study with a control group and an experimental group. And the experimental group, which was the ones that smoked 4 packs a day, on average lived 5 years longer than the control group who didn't smoke.
It doesn't come for other variables.
Well, assuming it was done well, it should have. But I'll take that as non-sampling error. I love that. Thank you, Lauren. Let's assume we have accounted for everything else. Exercise, diet, everything else. Thank you. That's perfect. They'll always ask that question. Could you have gotten random goofy results? Well, by chance? Outlier results? By chance? The only way to rule them out as outliers is to do the study again and again and again to establish that these are in fact outliers and not norms. Because if you replicate the study that smoking makes you live longer 5 times in a row, I'm nervous. We're all nervous. It's not going to happen either. So that's why these psychologists promise to replicate surprising findings before touting them. This is one of my favorites down here. Our World. Unemployment rate jumps from 7.6% to 7.8%. I call bogus on that. Look at the mathematically literate world headline. Why is the mathematically literate world article or headline more accurate than the Our World headline?
A lot of factors.
Well, assume the factors are controlled. I love the factor back here, this little factor team. Let's talk about the factors.
I know that they don't consider factors when they calculate that. Then
Suppose, even if they did, Laura, let's give them the benefit of the doubt and say they did. Go for it mathematically. When they say the unemployment rate jumps from, let's say it's 7.6%. Let's say it was 7. When they say it's 7.6%, what does that number mean? 7.6% of their sampled are unemployed. What's the population unemployment rate? 7.6%, looking for a phrase.
Population.
Starts with a P, not that one though. Starts with a P, has the word or in it. Also, in other words, starts with an M in it. Boom! Say it louder. plus or minus something. The only way you could say it's 7.6% of the population is if what happened? You went and asked every single person in the population. Did they? Hell no, they didn't. They never do. They can't. You couldn't. By the time you got done, you have to start again. And it would have changed while you were doing it. If you ever got done in the first place. So that 7.6% has to have a plus or minus on it, correct? So in order for it to have jumped from 7.6 to 7.8%,
Didn't really jump.
probably not, right? The only way it could have jumped, as in meaningfully different, is if the plus or minus was no more than what? 0.1%. 0.1. Because 0.1% on 7.6 will be 7.7. 7.8 down 0.1 is 7.7. Any bigger margin of error than 0.1, and those two things are indistinguishable from each other. Remember the Alaska Anwar drilling article from Gallup? Same argument. When's the last time you read a Gallup poll or an unemployment rate poll with a margin of error of less than 0.1%? Put your hands down, they don't exist. In order to have a margin of error of 0.1%, you have to survey like 150,000 people. And they don't do that. They usually survey around 2,000, which is plenty for a 3% margin of error. But it's nowhere near enough for a 0.1% margin of error. So the fact of the matter is, the reason this headline is better is realistically, it's the most truthful too. Rory, go, please.
Isn't their target like 5% too? So like,
Maybe.
well, I think that Carol said that the goal in economics was to be 5%.
So 1 in 20 are unemployed?
So like, it's never really above 3%. Really, like it never has.
Oh, I see what you're. Well, actually, if the target.
Actually, because that accounts for like all the fluctuations in the job market and just
Absolutely.
actual-
You know what, Rory? If the target's 5%, we're there.
Yeah.
You can't prove to me we're not. If that has a 3% margin of error on it, right? It might be below 5%.
Yeah.
So we're done. Stop talking about it. Or we might not be done. It might be much higher than that. See, that's the problem, is that as soon as you put a margin of error on it, the 5%, the point value of 5% gets eaten up by the interval. Yeah. Why does the 5%, where does that come from, out of curiosity?
I took macroeconomics and Carol just said
That was the number?
target for.
Austin, you've heard this too, I'm assuming?
Yeah, that's like the best unemployment rate I think we've had or any.
So it's historical.
No, the best
Well, that's-
was during World
yeah,
War
that's
II, and it was like 1, but that's.
That was post World War II,
Yeah,
a
but that's
little
like
artificial.
unattainable, so they go for like.
Is that why we're always at war?
That's
Maybe that's why we always go to war. We're going to go to war to make the unemployment rate go down. I'm not trying to make light of that. Any veterans in here, I'm not making light of that at all. I'm saying that it's kind of unfair to compare a post-World War II rate, for example, to what's happening right now, because there were artificial circumstances that caused low unemployment. Also, like WPA era things where Roosevelt put people to work somewhat artificially. And if you go to like Timberline Lodge at Mount Hood, you're like, holy crap, look at this thing. That was built entirely by people that were unemployed 6 weeks before and are now cutting 3.5-foot wide logs into these beams that made this gorgeous structure, which then becomes The Shining. But nonetheless, a little bit artificial when you use forced employment, if you will, to some degree, to compare to unforced employment here. So yeah, I'm not saying that that's not rife with issues. I was just curious where 5% came from. I had no idea.
Yeah.
5% is a popular number in statistics, and I was curious if it had the same kind of thing. Maybe it does. Maybe it doesn't. Sounds like we're not quite entirely sure. But I like your guys' reasons. I'm an economic idiot. I know nothing about it, so except that I can argue this pretty well. But if you want more, by all means, if you want more, the website's up there for you to go to. Yeah,
So 150,000 people is what you have to sample to get a 1% margin?
I'm doing the math in my head. I can give you a better, give you a better estimate.
Yeah.
I have a program that actually does it for me. I really do.
Yeah.
You have to do 1.97 squared over 0.001 squared times 0.25. I don't want to do that, because we're on a program. Sample size count, 95% confidence, I'm assuming. Margin of error of no more than 0.001, 960,365.
900.
Yeah, so if you get 1 million people and get your 0.1% margin of error, which means 1 in 300 Americans, it's worse than I thought it was. That's what you have to do a math in your head. So yeah, that's what you have to get no more than 0.1% margin of error. And we're getting a look from Sarah going like, what the hell, that's ridiculous. It's in 244, we'll study the mathematics of that calculation. The reason it goes up so quickly is because the margin of error, the 0.1% in this case, is quadratic. In the function, it's quadratic, whereas the confidence, or the percentage itself is linear. So if you want to say have your margin of error, you have to quadruple your sample size to accomplish that. It's Prattle. Remember what Prattle is like? Look at one branch of it. As it goes up, it gets steeper. Think of this as your sample size, where this is your margin of error. You know, this might only go this much, but this rockets. And that's, again, 244, we'll study that at great depth. I didn't realize it was that bad. I was off by a 0. My apologies. Don't tell Bruce, he'll kick my ass. So anyway, this is why we care about variation, because you can only have meaningful discussions when you consider the variation with the center. All of these deal with some center. This one in particular, there's your centers right there, centers of your sample. Ignore the variation, you might as well ignore the entire thing, because it's meaningless. It's meaningless. All right, here's some takeaways. I do want to get back into the construction of these things and the discussions of these things. Today, I've got some data sets to play with. The height, I don't think is going to work out very well. Maybe, we'll see at the end of the day, maybe we can play with it. But here are some big takeaways. So this is, I think if I remember my notes from Tuesday, or at least if I remember my memories from Tuesday in the class, I think we came up with most of this. Lauren, I know for a fact you just told me this. And Natasha added on the average bit, on average, the average distance. So we definitely have that. This might or might not be clear. A standard deviation by itself doesn't make any sense unless you put it with an average. So for example, if we talked about Bert and Ernie last time, based only on their standard deviations, you say, well, Ernie's a better student because his standard deviation was 1, whereas Bert is less consistent, his standard deviation is 16. But what if Ernie's average was 20? Then he's consistently crappy, right? 20 plus or minus 1, but it wasn't. It was 81 plus or minus 1. So you have to have the average. So in other words, you can't have the spread without knowing where the spread is. The margin of error of 3%, right? You might say to yourself, okay, so how is Congress doing? Do most Americans approve of how Congress is operating right now? Well, the margin of error is plus or minus 3%. Is that around 90%? Is that 90% plus or minus 3? Is that 50% plus or minus 3? Is that 10% plus or minus 3? I.e., it's 10% plus or minus 3. Just so you know, it hasn't gotten much better since... When did Congress become Congress? 1700s? Yeah. So, you have to pair it with an average. That's why I have that line drawing between center and spread, dispersion. And there's different words for it. There's variation, there's dispersion, there's spread. They all mean the same thing, scatteredness. This is kind of a big takeaway, or a small takeaway, and I put these in quotes. When S is big, scattered data. When S is small, clumped data. Why do I put big and small in quotes? Say that again, nice and loud.
It's relative.
It's relative. What a large standard deviation in one data set might be a small one somewhere else. Yeah, anybody ever tried to put like a bolt into, you're building a kit from IKEA or some do-it-yourself kind of kit, and the bolts and the bolt holes don't line up very well, and it gets frustrating, doesn't it? It pisses you off. You're like, oh my god, and you have to drill out and like make the holes bigger sometimes, depends on how cheesily it was made. The standard deviation on those measurements is tiny in those sets. I mean, if the hole is anywhere near where it should be, you're talking about standard deviations of hundredths of an inch most likely. But it should have been thousandths of an inch. But it was hundredths of an inch. Well, that's tiny, isn't it? That's small. But it's actually too big. It's bigger than it should be. That's why I put it as large. That's a large deviation when your unit itself is so incredibly tiny, or it should have been off. So, big and small become relative statements. You can compare 2 or 3 different data sets using standard deviations, but very often you're only looking at one data set and its standard deviation, and you have to get some meaning from just one data set and its standard deviation. And that's what I want to spend the rest of today and probably into Tuesday talking about, one single standard deviation by itself. So we'll come back to this for sure, but I want to focus really on how do we deal with just one data set and its standard deviation. What can we get from that? I mean, yeah, you can get the average distance, but can we get anything more from it, right? So, I wanted to use our height data, but unfortunately, the height data it's too small of a data set to get any kind of behavior from. So, grab that data sheet that I gave you guys. Some of you guys just picked it up. I brought backup data just in case.